Welcome. Today we'll be doing chapter number 22 for ICSE class 10, that is cones and spheres. Cones and spheres, the solid cylinder will be forming the base from which the other structures are created. Let me explain how a solid cylinder is formed and the basics of a solid cylinder. In the figure, you can see the solid cylinder, which consists of essentially one surface at the top, surface number 1, one surface at the bottom, surface number 2, and the curved surface surrounding this. Let me call this of radius small r. So when I want to calculate the surface area of this cylinder, it's nothing but surface area of 1 plus surface area of 2 plus the curved surface area of 3. Are we clear about this? What is surface area of 1? That is pi r square, this top area, and the bottom area will be plus another pi r square. And let me call the height of the cylinder to be h. Okay. Now, what is the surface area of this? We know that the circumference of this circle is 2 pi r. So when I want to know the curved surface area, how many such circumferences are available over this height? I can say that 2 pi r times h. So 2 pi r times h. So the total surface area of this figure would be 2 pi r square plus 2 pi r into h. This term is coming because we have h circles, each of circumference 2 pi r. So that is effectively 2 pi r into r plus h. Are we clear about this? The case of solid cylinder? Yes. Now let us take the case of a hollow cylinder. This is a case of a hollow cylinder. In this case, you can see that the inner radius is small r and the outer radius is capital R. And again, we'll consider the same height of h. We can see that if I want to take the surface area of this particular hollow cylinder, how do I consider this? We can see that at the top we have this portion cut out. Okay, so what is this portion? Let me call this 1. I should take only the hatched area, right? So this portion 1, if I want the surface area, I should take it as the surface area of 1 plus similarly the surface area of 2 plus surface area 2 plus similar to case 1, I have the curved surface area. Curved surface area of this figure, that is 3. Now, what is the surface area 1? We can clearly see that it is the area of the circle of capital radius r minus the area of the circle of small radius r, because this portion is cut out. So I can write this as pi into r square minus r square. Again, for the bottom face, pi into r square minus r square plus 2 pi capital R h. So this becomes 2 pi into r square minus r square plus capital R into h. Are we clear about this? So this is the surface area of the hollow cylinder. But have we missed out something? Yes, what is that? If you can see, since it is hollow, we have the similar curved surface area in the inside also. What I mean is the internal surface area, again it is a curved surface area of this portion curved surface area 4. So I need to add here curved surface area 4, so that will be 2 pi r h, where I take the small r. So this equation becomes plus 2 pi r h. So this will be 2 pi into r square minus r square plus r times h. Is this clear? Now this is the surface area. Now another case is we need to see the volume. What is the volume of this particular solid? We know that if I want to fill water in this cylinder, I can fill it to what level? This area into this height. So that is nothing but area into height, that is pi r square into h, that is pi r square h. What is the case of this hollow cylinder? What will this volume be? Here also we know that we can fill it only to the same volume. Is it correct? What is that volume? So we can see that this particular volume is pi into, in this case the volume is pi into V. Volume is pi into r square minus r square into h, because this is the effective area available, this area into h, because only this much area is available for us. Okay, I hope this covers the case of solid cylinder and the hollow cylinder.